Hello, my name is David Bytow, and welcome to Always Be Coding. And tonight, I'm going to solve 3 coding problems as quickly as I can, but also explain what's going on. These are going to be 3 easy problems, very easy to easy, and I'm going to do them in Go. So let's get started. The first one is access level. And so what I'm going to do here is I'm going to just read the problem and then essentially code the thing, right? And explain what I'm doing a little bit. I'll speed up over certain parts, but so we can get through this quickly in the interest of time. Start with this README. I should say I pulled these problems from various sources like TopCoder and whatnot. So I did not write these, and I'm seeing them for the first time, essentially. So we'll go from there. And I'm drinking a little bit of scotch, so that's fine. Okay, problem statement. In many computer systems and networks, different users are granted different levels of access to different resources. Okay, fine. So in this case, you're given a rights, okay, indicating the privilege level of each user to use some system resources. You're also given a min permission. You are to return a indicating, wow, which users can and cannot access this resource. Each character in the return value corresponds to the element of users with the same index. A indicates the user is not allowed access, while D indicates the user is denied. Okay, method signature, string can access, rights, min permission, okay. Users will contain between 0 and 50 elements. All right, so let's just jump to the examples here. Here's a bunch of users with their privilege level, and 2 is the minimum access level, and so this returns DDAAA. Okay, so that means because these 2 users have they're 0 and 1, and that's less than 2, so they don't have access, so it's D and D. And then these 4 users all have access, so 4 A's. Okay, makes sense. So let's look at another example. Let's see, access level is 20. None of these have 20, so that would all be denied. So all D, makes sense. No users, empty string, fine. And access level 49, and there's this one are allowed, and these 2 are, the rest are access denied. All right, should be easy. So let's jump to our problem. So I created this package called access and a test that we're gonna write against that. So I'm not gonna write the test first, I'm just gonna jump right into this and see what we can do. So let's create our function can access. This is what our test is going to call. There was an array of integers, I think, and required level int. Let's pull this over here, actually. Okay, so can access, we get a bunch of users, and we have to make a string. So first thing we'll do is make a string, so we'll just say access string. And then we'll loop through all of the users. So we'll say for all users and their level range. So we're gonna get each level, and then if, wow, this is really easy. If level is less than access, or sorry, required level, then we append a D for denied, else access. Okay, I guess that's that. Return access. Okay, that compiles. So let's write our test example access. And so the way this works real quick is we expect some output, right? So it goes example harness, looks for output from standard out. So in this case, for the first test, it'll be DDAAA, and we're gonna pass in the right thing. So first we'll print out. All right, pass. So let's make sure this is right. So we'll just make this wrong. Okay, that failed. Good, so that seems like it works. So I'm gonna go ahead and add the rest. That. So let's run this. Uh-oh. What did I mess up? Oh, are you kidding me? This is so stupid. I'm an idiot. Right, so, okay, of course. This range returns first the index and then the actual value when you're doing it. So I was comparing the index against it and happened to be fine for the first one because we're dealing with this. This is actually, anyway, it doesn't matter. Works now, all's good in the world. That was pretty easy. Let's get rid of this print statement and declare victory on that one. All right, that was pretty easy. Let's go to problem number 2. And this is I already read this one. It's a lot of words. Basically what you're doing, what you're supposed to do is assume that you're gonna take a strategy against a series of moves that the computer or the opponent is going to make. So the way we're going to, or the strategy we're going to take here is, after making 2 consecutive moves of the same kind, this is the opponent, the next move is likely to be the same as the previous 2. So that's the assumption we're making. But after making 2 different consecutive moves, the next move is likely to be different. So if the opponent does rock and then paper, then we assume the next one's scissors. If they do rock and rock, then we assume it's rock. And if it's not, then we go from there. So I have to calculate how many we would win if we followed that theory correctly. And so the inputs are the moves that the opponent is making and how many wins we would have. Oh, your first 2 moves are always rock. Okay, so they would play, say for the first one, I'm gonna play rock and they play paper. That means they win, and then they play scissors, and then we're following the rules, so we play rock again, and we win, so that returns 1 win. Okay, so let's look at another one. So the first 2 we're gonna play rock again. So it would look, our moves would look like this. Rock, we would lose. We play rock again, we would win. And then we look at the last 2 and go, oh, so they played paper and scissors, which we assume now they're gonna play rock. And so we would then play paper. And of course they do end up playing rock, and we win, so that's another win. And then we look and go, oh, okay, they played scissors and rock, which means they must play paper. So then we would play scissors, but we would lose because they would actually play rock. So that's 1, 2, 3 wins, and of course 3. Okay. And here's a couple other ones that I'm not gonna go through, but these are other examples. So let's just code this up and see how we do. Okay, so we'll start with this package, and really this is just a bunch of just some simple logic. So make our function, oh, what was it called, wins? Let's say opponent, really it's actually moves, and number of wins. Okay, so let's count our wins. So what we're gonna do is let's iterate through all their moves. It's really their next move. So I'm gonna split up the string here so that we get each string as a, or each thing here is a separate string, each move. Okay, so then our move is going to be assumed to be rock. I mean, that's our first 2 moves anyway. So then if I is, let's say, less than 2, well actually if I is greater than 2, then we'll apply some logic. Otherwise, we just assume we're playing rock and we see what happens. So now that we know that we're looking at the 3rd move, or 3rd, 4th, 5th, we should split up. I'm gonna take their last 2 moves here. So that's what this is doing. That's saying take from 2, if I is 3, or let's say I is actually 2, then this would be 0 to 2, and so it's exclusive, which means I would get move 0 and move 1 index, so that's the last 2. So we expect, let's say that I'm gonna make an expected variable, which is like, what do we expect them to do? And I'm just gonna put that to R. So let's create a switch statement here. Okay, so what do we want to do? Well, we're gonna look at the last two moves, and let's just enumerate these out. So for example, let's say it contains, I'm gonna say, what is this move? This is really, and this could be better, but let's say it contains this other, last two moves are both rock and paper, okay? So then we expect them to do scissors. And then we can copy that, I think for 3 cases, I think we need. So it's what, rock and paper, then rock and scissors, and then say paper and scissors. And that's the 3 unique cases. We don't care about order here. This is just checking if any of this whole string has both of these characters, which means they're both there. So if they play rock and scissors, then we expect it's going to be paper. And so then we would play scissors. Oh wait, is this right? We expect they're gonna play, yes. So we expect they're gonna play paper. And here if they played paper and scissors, we expect they're gonna play rock. Okay. So then now whatever we expect, if we expect they're gonna play a scissors, and we would play rock. And so on and so forth. Okay. So that would be our next move. So now what we can do is now we have our move, and then we can look at, okay, what's the actual move that they made? So let's just do I'll just do a simple if statement. Say if our move is rock, and their move is scissors, or our move is scissors and their next move is paper, or, which means we win, or our next move is paper, and their next move is scissors. Actually, sorry, rock. What am I thinking? Then we win. So wins plus plus. Is this what happened here? Oops. Okay, so then should return how many wins. Okay, I'm gonna write the first test real quick. Let's put this over here. Oops. So we'll do PS, and we expect that this is going to produce 1. So let's run that. Cool, let's just Hail Mary this. I'm gonna add the other ones. All right, moment of truth. Nope. Got 1, 3, 7, 16, 14. This last one got screwed. Expected 18. Is there, oh God. Let's look for a simple, obvious problem here. I bet it's 1 move off. Oh, of course, forgot this case here, where if they moved twice, we just assume it's the most recent move, which is actually, I guess, prev 1. Okay. Oops. Now let's just do this. Oh yeah, we could do that. Prev 1, turn it to a string. Actually, it's prev anything because they're both the same, so it doesn't matter. Okay, now let's try this. 1, 3, 17. Oh, 7. This is from, I copied that wrong. Cool. All right, that's done. So that was a good one, and let's do problem number 3. Okay, 2 phrases are anagrams if they are permutations of each other, meaning they have the same letters, but they're just scrambled, essentially. Ignoring spaces and capitalization. For example, this thing is an anagram of anagrams, TopCoder, anagram of dropcode. Okay. And then given the phrases, remove each phrase as an anagram of an earlier phrase and return the remaining phrases. Okay, given a phrase, remove each phrase as an anagram of an earlier phrase and return the remaining phrases in their original order. So string, array, anagrams, phrases. TopCoder. So this is an anagram of this, which means we remove it. This is an anagram of this, so we remove it, so we're left with only these 2. Okay. So all of these, I guess these are both anagrams of this. So we're left with only that, because these are removed. Func anagrams, phrases, string. Okay, so here's what we're gonna do. Right, so these are the same. And so what we can do is if we take, we go one by one, and we take it and then we mutate it in some way where these are basically equal. So imagine we take this, we take this and we sort it, and then we remove the spaces, and lowercase it. So first we lowercase it and then we sort it, and then remove the spaces. They'll be equal to each other, right? So, you know, well, I don't think I need to do that, but like, let's say I'll just do one. So TopCoder, whatever, it'll look something like that. Whatever. And this will do the same, this will look the same once we've done transforming it. So then we can put it in a map or something and check to see if we've already found it, and if we have, we drop it, otherwise we keep in the list. So that should be pretty straightforward. So let's make a map, just booleans, doesn't matter. And the anagrams we're gonna keep. Okay, so go to the phrases, and so first, let's say, we'll call key string. So first we're gonna lower case it, and then we gotta sort it. So Go doesn't really have a sort for strings that I know of, and the string is made up of runes. So let's just make a function to sort string. I'm gonna write this out real quick and then explain it. What I'm doing right now is I'm satisfying an interface for a sort interface, basically. And it expects for this to have, right, so I've aliased this to an array, declared this interface. Now I should be able to call sort runes, see if that compiles. Right, so then let's sort that, sort string. So we sort it, and then let's remove spaces. So I know spaces, since A to Z, spaces will be at the front or the back. So I can just do trim space from the string. Now we got its key. So let's do this then. We can say, okay, if it's in the map, so this returns a boolean here. So if this key is in the map, or not in it, sorry, then we can put it in there, or set it, say yes, it's there, and then add it to our list, and then return anagrams. Okay, that compiles, nice. So let's go over, I'm gonna write a test. This returns, let's change this real quick. What's this return? The string. Let's just make it easy here. That's fine. Strings.join, and then we'll just make it a comma delimited string. Okay, so now we should expect output is just this one and this one. Let's try that. All right, let's make sure the other tests work. All right, give that a shot. Test pass, let's just make sure. All right, failed. So that's it, easy, simple. All right, well, that was pretty fun. I always enjoy doing these sorts of things. I'd like to do some more difficult ones later, you know, cover different topics, use different languages, so on and so forth. If you like the video, please leave a like, but especially please do comment or subscribe. But I'd love to hear from you and see what you're interested in seeing. So, you know, I respond to every comment, so let me know. In the meantime, always be coding.